Hello everybody and welcome to today's class. We'll be talking about scrapers today. So without further ado, let's get started. Um, this is how a scraper looks like. There is a variety of scrapers in the market and you would see them in many construction projects that include some kind of earthwork operations. Based on the need, you could have scrapers in different sizes, different capacities, and different types. Some of them have one engine, some have two engines. So in this lecture, you will learn about scrapers. You will learn about their applications. What do we use a scraper for? And what are different types and what is each one useful. But before we get started, let's watch a video that shows scrapers in practice. So this is how they are moved to the job site. As you can see, they're pretty big machines. Yeah. So you will see this is a type of scrapers that could be combined with a loader, okay, that pushes it. Pretty big machines. As you can see, the two machines have been attached. This is how the attachment happens. As you can see, it's pretty easy and fast. So it can move the earth for short distances, and sometimes it is used to move earth for up to 300 feet. This is not the only type in this video. Yeah. So as you can see, this is the part that pulls it, okay? And the engine is in the front part. Well, there are scrapers with two engines, in which one engine is in front that pulls and the other engine is in the rear, and it pushes the load of the equipment. Okay, so with this introduction, oh, I forgot to pause this. Okay, with this introduction, let's take a deeper dive into scrapers. All right, so let me make sure this is working fine. Yeah. Okay. Scrapers, the main application of scrapers is moving earth or rock for short distances, okay, not for very long distances. Obviously, trucks would be more appropriate because they are lighter, they are faster, but scrapers have the possibility. I mean, what makes them special is that they don't need another loader to put the earth on them. So they have a mechanism by which they could just load themselves and then move the earth. Okay. This is what makes them different from trucks. They could be used for spreading the earth or, for rock fills. Second application, they could be used for backfilling, so they're not only used for loading, you could use the loaded earth or the loaded dirt for backfilling the trenches. Um, Operating up pilot roads through mountains or rocky terrain where a truck, it would be very difficult for a truck to operate and move. The scraper steps in and does the job for us. It can also be used for clearing the floors of burrow and quarry pits. So it has this application of clearing and grubbing, and I guess I have a good video to show you in next slides. Helping load tractor pull the scrapers, okay? So they could help load tractors and other scrapers. So this is another application and clearing land of timber, stumps, and root mat. Okay, so these are pretty important applications that a scraper has for us. But again, I emphasize the main advantage of scraper compared with a loader, compared with a truck, is that it does not need a loader. It can load itself and it can spread the load that it is carrying by itself. Okay, so it is a self-sufficient or independent machine that is capable of moving in tough road conditions with pretty good speed that makes it very useful equipment, heavy equipment. So what are the major equipment operations? It can cut, it can load, it can haul and spread. So sorry, these are the four major operations, okay? That when we are doing earthwork, most of the time we are doing one of these four operations. Now, what road factors should we take into consideration while selecting equipment? So this part is not yet about scrapers. We're talking in general. That four types of earthwork operations were cut, load, haul, and spread. Now, what are some of the road factors we need to take into consideration? Underfoot condition, obviously, depending on the surface condition, the choice of equipment could be impacted. Haul distance, for long distances you would go with a truck. For shorter distances you would use other haulers such as scrapers. Condition of the haul surface, such as the rolling resistance and grade resistance. For example, if you need to go up the hill, it would be very difficult for some equipment pieces to do that. But for example, for a tracker or a crawler machine, it does not matter. It can move with almost any rolling resistance and grade resistance. I mean, not any, but for many of them. So type of material being moved, yeah, for example, if you want to move rocks or very, heart shaped or the kind of material that has sharp edges, okay, then you probably cannot use a wheel machine. You should have a crawler machine. So this is just one example. Or alternating cut and fill operations means what percentages of cuts and fields you have, and how far they are from one another, how much soil you have to move. So the capacity, the job size also identifies type of machine that would be advisable. Okay, now as a project manager, you have been assigned to select between a scraper or a dozer or an excavator and trucks. Okay, so we have scraper, that's choice 1. Choice 2 is a dozer, and choice 3 is truck. okay, and excavator and truck. To excavate and move dirt, what will your decision depend on? Again, it depends on how far you have to move it, because you can do the job with all the three, okay? So in many cases, that's a very big question. That's a basic question in many earthwork operations, to choose between a dozer, and a scraper, and a truck and loader, okay? So um, you want to know, to answer that question, you want to know how far you need to move the dirt, how fast you want, what speed, how high you want your speed to be. Are you in a rush or no? Time is not of the essence, but you want to spend less money. What type of dirt it is, okay? That soil type matters a lot. How wet it is, which identifies how easily you could play with it. Is it too hard to work with, or is it, flexible? How deep is excavation? Um, so depending on the depths, you could go with different types of equipment, and what you're doing with soil that you excavate. Okay, do you want to spread it afterwards? Do you want to haul it to a different location? Do you want to use it to backfill a pit or a trench? So it all depends. Most of the time, when you could use it in place in the location, it would make sense to use a machine that can do a job. That can do the loading part and then unloading part by itself. So instead of having two operators, two machines, and spending more money, you could do the whole thing with a single machine. Now, let's look at the right part. So we want to compare scraper and truck. Scrapers can dump its payload in uniformly thick layers. Okay, so uniformly is important here because it enables compaction and then finishing the operation. It accelerates it. It makes it easier. So compare the case that an excavator uniformly spreads the earth with the case that a truck just unloads its dirt in big stocks, and then you need other machines to spread it and make it even. So it increases compaction while doing that, right? Because the load of the scraper itself will be exerted on the road surface, and that will contribute to the compaction of the soil. And in good compaction, uniformity of the soil goes a very long way. It's very important. And using the scrapers, you have a free mind. You know that you will get a pretty good spread for your dirt. So let's compare a scraper and a grader. So both of them are standalone machines that can do the job. Yeah, they can do finish grading, which in case of other machines. These two machines can do finish grading, which is important for us. Okay, they can lean and gauge the ground. Okay, so both of them have this capability. Scraper for asphalt removal. They can remove asphalt paving that are up to 4-inch thick. Okay, that's pretty a lot. Okay, that's almost a lot. So it can shave the asphalt from the surface of the road, and by it I mean the scraper can, and the rippers can be installed on a scraper blade. So how about the case of scraper versus dozer? Okay, So if the dozer could do a better work than a scraper in all conditions, there will be no need for the scraper, and vice versa. Yeah, I know that's not a very exact, or that's not a very neat answer. It just says whenever you can do the job better with one of them, just forget about the other, which sounds obvious. But anyway, it provided us with some insights about making comparisons, right? Between a scraper and a truck, especially, there was a good comparison that the truck cannot spread the soil while the scraper can spread it in uniform levels. It accelerates the compaction process because you have your layers already and they are uniform, and the weight of the scraper could help could contribute to some compaction, okay? Scraper and grader, we mentioned that both of them can do finish grading, so they're both good. In case you need to remove the asphalt paving, scraper is preferred because it can easily, thanks to its rippers, it can easily shave the asphalt as thick as for up to 4-inch thick. Okay, so we have a slide talking about different scraper types. Okay, so looking at these two pictures right here, if I can get my mouse, yeah. What do you think, looking at them, what do you think is the main or is the most important difference between them? So if you look more carefully, this scraper is only pulling earth. For the second one, you can see there will be two engines. One is the front engine that pulls the load, and the one in the rear can push the load. So its power will obviously be more than a single engine scraper. Okay, so we have single powered axle. Okay, single powered. By single powered, we mean there is one engine. Okay, and if there is one engine, that engine always pulls the load, not pushes it. We have tandem powered, or so they have dual or they have double engines, one in front, one in the back. Okay, we have self-loading scrapers. Okay, for self-loading scrapers, as implied by the name, they can put the earth, they can elevate the earth and load themselves. So they could be elevating, and there could be push-pull tandem powered axles. Okay, so you have the ability of having two scrapers one after another. They come in a row, and there are some benefits, like sometimes one can push the other, sometimes one can pull the other one that is in the front, so their power could go hand in hand and create more power for the machine's movement. Let's watch one video about these scrapers. So as you can see, there are two engines. One is in the front, the other one is in the back. You see how it is loading itself, right? And it can do both loading and spreading at the same time. Okay, now another scraper comes for help without even needing someone to attach them. they could be easily attached in a few seconds. Okay, the engine is powerful enough to pull the second scraper, but anyway, the second scraper has got its own engine. So as you can see, smooth surface is the result, and the remainder of the job, you see how it is pulling, the remainder of the job is completed by the second scraper. So this is obviously useful for highways, for roads where there is sufficient, length. I mean, the machines won't have to go back and forth a lot. There is sufficient, length. Okay. So this is how push-pull or tandem-powered axles work. And another video for elevating scrapers. Yeah. So if you remember, the wider are the wheels of heavy equipment, it creates more tractive force. Okay, I mean, the machine would be moving on the road surface more easily. Okay, so you got some understanding so far about different types of scraper and how we could attach the two of them to increase their capacity and to, increase the production rate of the job. So there are some advantages of that. And we mentioned that it is particularly useful when the machines are going to move in a in a road or in a highway with sufficient length. I mean, they don't have to go around, okay, and turn around. All right, so already watched the videos. Selecting the right hauling equipment based on the haul distance. So as you can see, this is provided for us, and as you can see, it is based on, put myself in the center, so it is based on some estimates. There is not a very certain limit that, below that you would go with one equipment and after that you would go with the other. But look at the distance. So this is the haul distance. So it depends on two things: haul distance and the type of material. The type of materials. So in shorter haul distances, you would go with a self-loading scraper. Okay, but for longer, like I mentioned before this slide, for longer distances you can use push-loaded scrapers. That's when you attach two scrapers and they push the load. So this is about the distance, but we also care about the type of material we have. So if the material is easy to load versus the material is, rock, which is hard to load. So for easy to load, scrapers are okay, are very nice. And for, harder type of materials, you would use articulated trucks or other trucks. So you can get some understanding about the type of, and the black area means you can go with either of them. Okay, So to wrap it up, scrapers are good for soft materials and low haul distances. If it is a low haul distances, you would go with a self-loading scraper, but for longer haul distances, in case you're using a scraper, you would use a push-loaded scrapers. In terms of the type of material, for soft materials, scrapers are good. For rock and harder materials, you would go with an articulated truck or other types of trucks. All right. So scrapers are best suited for large open areas. As you can see, the machine is a giant machine, so it takes a lot of space and there is a lot of blind spots when you're using it. So you won't be able to use it in a very narrow and where the ease of, there is not a lot of space for maneuvering. That's really tough to use a scraper. In those areas you will not. Scraper is preferred, it's best to be used in large and open areas. Okay, the ideal condition for a scraper are soft materials. As you saw in the video, the material was very soft. So they cannot work well on rock and hard materials. So easy loading materials and sandy, for example, sandy silt soil would be an ideal option for scrapers. We have another video. So as you can see, this is a very large area and you can see a lot of scrapers. That would line up and do the job. They can go in with different slopes. You can see the double scrapers. We obviously need 2 operators for them, but the power and the capacity will be increased, if not doubled. Yeah, most of the time when you're using a more than one of them simultaneously, each one will be assigned to a particular lane, and then they could move together. All right. So, the type of projects for which scraper would be helpful. Actually, there is a variety of them. Here I have the list of different projects and I will show you for how many of them you could use a scraper. In airport projects, they're a good choice. Obviously for highway construction, for land leveling, for overburden removal, for railroad embankment, for site preparation because it has some clearing and grubbing capabilities, and for stripping. Okay, for all of them, scrapers can do the job for us. So we talked about pull type scrapers. It means the engine is actually the engine is in the front and you can pull the scraper. They're not necessarily an equipment. A tractor could pull them, okay, but obviously they are not useful for for big projects. But they have actually a lot of functionality in small projects, but you need a tractor to move them. So Conventional push loaded with a dozer. Yeah, so um, as you can see here, a dozer, okay, is, you know, is pushing is pushing the um, is pushing the scraper. Okay, so let's watch this video to see what is the mechanics of this. As you can see here, yeah, so the loader is providing more energy for the front scraper to go ahead. This is particularly useful when you're working on road surfaces that are, you know, that are harder, or when you're working on uphill slope. Okay. So again, single engines and twin or tandem engine. So remember, they are the same thing. Twin or tandem engine. Twin engine scrapers are good for jobs having adverse grades and poor footing, right? Because you have additional power. So self-loading scrapers, give me a second. Okay, push-pull scrapers. This is push-pull. The operator at the back pushes the scraper in front for loading. The scraper in front then pulls the scraper at the back for loading. So it's not like that one of them, I mean the one in the back is all the time pushing the one in the front. Sometimes it's vice versa. I mean the front scraper could pull the back scraper. So it's like they work hand in hand to step in where more energy is needed, okay, which is provided in terms of pushing or pulling, after which they both disengage and independently haul their load to fill. Yeah, so most of the time we only engage them when it is required. Excuse me. So when the grade condition or the grade or the, you know, footing condition is adverse, so more energy is required, they can be attached, and then you would disengage them so they can move independently. And since attaching and detaching them is very fast and easy, you could do them many times in you know, in one pass. So push-pull scrapers are twin engine scrapers with cushioned push block and bale mounted on the front and a hook on the rear. Yeah, so there is a mounted bale here and there is a hook on the rear, okay, and this can be moved, you know, automatically. The operator does not have to get off the machine. They can just control the hook from there to engage and disengage their car, their machine. Push-pull scrapers can work as a team or can operate individually with a pusher. Okay, so again, elevating are good for short hauls and in favorable material, and so yeah, we already introduced them. What here it is telling us some applications of them. They can work alone in the cut. They cost more initially and to operate, okay? So elevating scrapers are expensive. So elevator adds weight and track power, and they are not used for rock materials because of potential damage to the paddle system, and that is a general rule, okay, for other types of scrapers as well. So let's see this video about them. As you can see, they're almost fast. They can elevate the load by themselves using this mechanism. Okay, so this is how they are structured. Another self-loading scrapers are auger scrapers, okay? So they have a different mechanism. Here you saw how it would elevate the soil from the road surface. Here they use an auger to do that, okay? They are specifically for, they are particularly useful for rock materials, which are harder to be elevated using this mechanism. Auger scrapers can self-load in difficult conditions, such as laminated rock or granular materials, okay? Again, the auger adds weight to the scraper during travel, and it is more costly to own and operate than a conventional scraper. So, but in case that the road surface has a lot of rocks or sharp edge materials, you would not be use a traditional or just a normal scraper. You would need an auger to dig to elevate the materials and haul it to the scraper. So other operations, they can bow. The bow is the loading and carrying component of a scraper, okay? So across its front bottom edge, it has a horizontal cutting edge. The bow is lowered for loading and raised during travel, okay? So they can help other scrapers using that apron. The apron is the front wheel of the bow, okay? It is independent of the bow. It is raised during the loading and dumping operations to enable the material to follow into or out of the bow. And the ejector is the rear vertical wall of the bow. The ejector is in the retracted position, okay, during loading and hauling. Okay, so what is the production cycle for a scraper? If you see this picture, this is a full cycle of a scraper. It starts with loading here, and then it continues with hauling the load, and then dumping, and then turning and returning, okay, and until it gets back to its original point. So this completes the loop. So we have to consider loading, haul travel, dumping and spreading, turning, return travel, and turning and positioning to pick up another load. Okay. Something that is a systematic analysis for computing the production cycle of a scraper is the fundamental approach for identifying the most economical. It is the fundamental approach for the most economical employment of these machines. It means by running different analysis, you could, especially this is good for queuing scrapers, okay, to put them in a line in a way that they provide enough distance for the next or for the previous scraper, especially when you're using a bunch of them, which is the case which is what happens in most cases. So by having a good analysis of the loading time, the hauling, dumping, returning, turning around, you can have a smooth queue or smooth line in which all of your machines are working with minimum disturbance to one another, and by providing freedom of motion for other scrapers. So the components of a scraper are shown here. The bowl is the part in which the earth is accumulated. This is the engine, the front part. The gooseneck is here. Steering cylinders, which are super powerful, and the ball cylinders to move the ball in up and down directions. The apron and the ejector. Okay. But the most important parts would be the apron, the ejector, and the bowl. So you should be familiar with those parts. So the attachments for grade control is okay. So you can use GPS systems, which consists of these parts: electronic control, which is in the cabin, okay, and then you have the position sensing cylinder. You have the GPS receiver, okay. So the machine, could be, the location of the machine is precisely controlled by tracking it, by being tracked by the GPS receiver, and the angle sensor is put there. Using all of them, you could control the movement of a scraper with a lot of precision. This is the ejector. So ball leveler, apron leveler, and ejector leveler. Okay, so this is how it shaves the earth. 3-piece cutting edge, or it could be a curved cutting edge, it could be a straight cutting edge, okay, depending on the surface type and other factors like the grade and rolling resistance. You would select one of them. So three-piece cutting edge, the middle blade is called the stinger, okay, this part. So volumetric measurement of scrape load, it could be both in struck or heaped, and you know the difference. For example, this is heaped. Okay, for hauling, this is what happens. If this is the direction of travel, when the apron lowers, it could collect the earth. The ejector is in the back, and the ball raised to permit free travel. Okay, and keeping the ball low enhances stability. Yeah, if you move it up, the machine will also use more gas because it will be unbalanced. The weight would be unbalanced. So spreading the load, the way it happens, if again this is the direction of the travel, so the apron will be raised, and then soil will be released, and this will help it to spread, and the amount that is released is controlled. That's why it could provide a uniform thickness, okay, An ejector moves forward to empty the bowl, okay? So this is how the ejector works. It gradually moves from right to left, or let's say from rear to front, okay? From rear to front to push the soil out. So compare it with this picture, okay? So ejector is all the way back now, okay? All right, let's talk about scraper safety a little bit. So some of the common safety issues with scrapers are number one, struck by, which accounts for 22% of scraper accidents. Almost 1 in every 5 accidents, more than that actually, is because struck bys. Cut in between, oh, that would be a very, a very tragic death. Accounts for 18% of scraper accidents. Okay, so one issue, if we can call it an issue, or one characteristics of these machines is that they have similar to a lot of heavy equipment, they have a lot of blind spots. Okay, so when you're moving the scraper, you should make sure, especially in backing the scraper, there is a lot of spots that you have no control. I mean, you cannot observe them. The operator cannot see what is happening in the back. So some safety tips are restrict and monitor access to the job site. Okay, so not everybody, not unauthorized people should have access, because, and sometimes if the scraper operator, for example, he is late, don't even be tempted to run the machine because it could be very dangerous. Maintain safe speed within a safe speed envelope. That is important. So the machine can move, the machine might be able to move faster, but you should always think about, is it safe to do that? Seat belts should be worn by operators. Although the machine is moving at very low speeds, it doesn't mean that seatbelt doesn't matter. That this might, sound obvious for everyone, but consider working in a very hot weather, and you're working in that cabin, and although yeah, there is air conditioning and everything, but still feel hot, and then you have the belt, the seat belt here. So sometimes the operator is tempted to just, to remove it, but because the machine moves very slowly, so you might think to yourself, why am I wearing this? But that is important, and you should have it worn at all times. So lower bow during haul to avoid imbalance. This is reason number one of, well, not reason number one, because there is one more. There's another reason that is more important than this. But when it is unbalanced, you are purposefully or maybe unintentionally increasing the probability of a collapse. So I mentioned this is not reason number one. When scrapers are working on grades, on on steep slopes, and in conditions where one side of the car is above or lower than the other, so this imbalance has, might cause the machine to turn over. Provide basic training for an on the ground worker. Yeah, especially when you have a lot of personnel. So in case of highways, when there is a lot of space, this is less. This is not the case really, but many times you're working in a congested construction area. You have the people, you have the machines moving behind the scraper. You need a guy, you need a person on the ground who can watch the surrounding of the scraper and make sure that and make sure that when it is, especially when it is backing, it is not creating potential hazard for anyone. Operators should always conduct walk-through inspections climbing into the cab. Yeah, so especially look at the wheels, look at other, I mean, when you look at around the vehicle, you get some understanding about what could be a potential hazard as you start moving the machine. So that's very useful before you get on the cab. Okay, that completes our lecture for scrapers. Uh, Great machines. I hope you all enjoyed it. I will see you all next time.